Okay, let's get right into it. Modern refrigeration and air conditioning. We're doing more electrical today. So let's figure out where the electrical is at. I guess we'll do chapter 14, servicing electric motors and controls, page 304. We're just going to start by reading like the learning objectives, the technical terms, review of key concepts, and introduction. Learning objectives. Information in this chapter will enable you to use different testing instruments to measure electrical variables in a circuit. Test motor winding insulation. And test motor winding insulation using a magometer and perform maintenance based on the measured resistance. Determine the cause of motor trouble by checking a motor's current draw, start and run capacitors, and internal temperature. Also, we will be aiming to learn how to measure a three-phase motor's voltage and winding resistance to test it for single phasing. Also, we will describe the ohmmeter readings that indicate a shorted winding, an open winding, and a short to ground in a hermetic compressor motor. We will start a stuck hermetic compressor motor by connecting a hard start kit to the compressor terminals. We will service fan motors by identifying connection problems, fan problems, and electronically commutated motor trouble codes. We will properly lubricate motor bearings and install belts connecting external motors to belt-driven units. And we will troubleshoot and replace faulty control system components such as thermostats and motor starting relays. Technical terms: ammeter, bleed resistor, bushing, clamp-on ammeter, continuity, end play, hard start kit, inline ammeter, magometer, multimeter, ohmmeter, oilless bushing, outside length, phase loss monitor, power factor meter, pulley, short cycling, single phasing, slip ring lubricating system, voltmeter, wattmeter, wick lubricating system, Zerk fitting. Review of key concepts. Reviewing these concepts from earlier chapters will help you understand new concepts presented in this chapter. The most common causes of motor failure are current overloads and overheating. Both of these conditions may cause damage to motor winding insulation. It's from chapter 13. Motors rely on the proper operation of capacitors, centrifugal switches, and relays to start and run efficiently. Chapter 12. The majority of electrical problems can be narrowed down to one of the following causes: a short circuit, a short to ground fault, a current overload, an unintentional voltage drop, or an open circle. Chapter 10. A hermetic compressor consists of a motor sealed inside the compressor dome, while open drive compressors, fans, and blowers are connected to an external motor by means of a direct coupling or belt. Chapter 12. A thermostat senses a conditioned area's temperature and sends a signal to the controller to either energize or de-energize the motor starting relay in order to keep the temperature at the desired set point. Chapter 13. Introduction. HVAC-R technicians must know how to test electrical circuits in order to properly troubleshoot and service electric motors and controls. The service of electric motors and controls also requires knowledge of the system design and an understanding of how electrical devices operate within the system. Consistently following good safety practices and being able to read wiring diagrams are the first steps to mastering a skill that requires practice and experience. However, an HVAC-R technician can still achieve a high degree of success regardless of skill level, by following an established procedure and performing electrical troubleshooting one step at a time. Safety is the most important aspect of working on electrical equipment. Power to a motor or control should always be shut down and locked out according to electrical code before any service is performed. Okay, we're going to skip a page. Voltmeter range switch. When measuring voltage, always set a voltmeter's range switch to a higher voltage setting than is expected from the circuit. For example, when checking a 120 volt circuit, set the range switch to the 240 volt setting. This prevents damage to the meter if there is a voltage surge. Ohm meters. An ohm meter is a meter used for measuring the electrical resistance in circuits. In addition to measuring specific resistances, ohm meters may also be used to check for short circuits, open circuits, circuit continuity, and shorts to ground faults. An ohm meter is connected in parallel with a load or circuit while a known voltage is applied by the meter. This known voltage is provided by a low voltage battery inside the meter. Ohm meter usage. Be certain to turn off a circuit's power before taking resistance readings with an ohm meter. Otherwise, the instrument may be ruined. Taking voltmeter readings across switches and electrical loads in series with the intended resistance reading to ensure that no voltage is present. Take voltmeter readings across switches and electrical loads in series with the intended resistance reading to ensure that no voltage is present. Okay, when measuring the resistance across an open switch, the reading should be either infinity or OL, overload. This means that the resistance is so high that the meter cannot measure the resistance value. Connecting an ohm meter in parallel enables a technician to check the continuity of a conductor or to measure the resistance across a device, such as a lamp, a heating element, or an open switch. When checking the continuity of a conductor, the ohm meter reading should be 0. If the meter reads 0 ohms, it means there is no resistance, which indicates that the conductor is not broken and that all the connections are good. If the ohm meter reads infinity, the conductor has an open or a connection is broken. Ohm meter measurements. Taking resistance measurements can be problematic in circuits. Whenever possible, disconnect a device from the rest of the circuit before measuring its resistance. Disconnecting both sides of a device may not be possible, but by disconnecting at least one leg of the device, a technician can ensure that the ohm meter reading will be across the intended device and not through the rest of the circuit. Be familiar with the circuit's electrical diagram to avoid accidentally taking an unintended or false reading. Ammeter. An ammeter is an instrument that measures the rate of current flow through a conductor in amperes. There are two types of ammeters, clamp-on ammeters and inline ammeters. A clamp-on ammeter makes it easy to measure current flow because it is not necessary to disconnect wires or attach leads to obtain a reading. Inline ammeters are connected to a circuit using leads to provide extremely accurate current readings. Most electrical work in HVAC-R can be performed with a clamp-on ammeter. Clamp-on ammeters. A clamp-on ammeter is an AC ammeter that senses and measures current based on the magnetic field produced by the alternating current flowing through a conductor. In the same way that a transformer uses a primary coil to induce current in a secondary coil, the current flowing through a conductor induces current in the coil of wire inside the clamp-on ammeter's jaws. The jaws can be opened, slipped around a conductor, and closed again. The current generated in the jaws by the conductor's electromagnetic field is measured by the ammeter and shown on a digital display. Clamp-on ammeters often have other functions as well, such as settings for measuring voltage and resistance. Only a single wire of a circuit should be placed in the jaws of a clamp-on ammeter. Current in an AC circuit flows through the ungrounded, hot, and grounded neutral wires to an electrical load and back. The current measured in either wire represents the current draw of the electrical load. If a technician places the clamp-on ammeter around both the hot and neutral wires, the currents will cancel each other out and the reading will be 0. Okay, that's 10 minutes.